Hello and welcome to episode 35 of George's Random Astronomical Object. So I occasionally get asked, how do I choose an astronomical object for one of my podcasts? And the short answer is that I don't actually choose the objects myself. Instead, I use a random number generator to generate coordinates in terms of rise, ascension, and declination. This is the astronomical equivalent of longitude and latitude, and I then search for an astronomical object near those coordinates and talk about what I find at those coordinates. So it's the random number generator that effectively chooses the object for each and every episode that I do. So now, having described this, let's turn on the random number generator to produce the coordinates for this episode.
Modulation.
And the coordinates that came back are 13 hours, 23 minutes, 55.5 seconds rise ascension, and plus 54 degrees, 55 minutes, 31 seconds declination. These coordinates point to the star Mizar. If you've done a little bit of amateur astronomy, then the name Mizar might be a little familiar to you. Mizar is one of the stars in the Big Dipper, which is also known as the Plough in the UK and Ireland, and which also forms the bright part of the constellation Ursa Major. Mizar is also very close to the star Alcor in the sky, so I'm going to be discussing both of those stars in this podcast. If you identify the group of stars that contains Mizar and Alcor as a big ladle or spoon or dipper, then Mizar and Alcor are the pair of bright stars that are second from the tip of the handle. If you identify the group of stars as the posterior of a bear, then Mizar and Alcor are second from the tip of the bear's tail. If you identify the group of stars as a plough, then I suppose that Mizar and Alcor are second from the tip of the handle of the plough. I don't really see a plough when I look at these stars myself, so I really can't tell you which part is supposed to be which. The name Mizar seems to have come from medieval Arabic astronomers, although the original Arabic name was Al-Marak, or the loins. It seems like some sort of translation error resulted in the name Mizar. Rather strangely, one of the other stars in Ursa Major was also called Al-Marak, and that other star is now called Merak. Mizar, which has a magnitude of 2.0, also has the designation Zeta Ursa Majoris, with Zeta, the sixth letter in the Greek alphabet, used to indicate that it's the sixth brightest star in the constellation. Alcor is much fainter than Mizar. Its magnitude is 4.0. Since it's fainter than at least 24 of the other stars in the constellation, Alcor doesn't have a Greek letter to identify it, so it has the alternate designations of either G Ursa Majoris or 80 Ursa Majoris. It also has a few different Arabic names, including Suha, which means the forgotten one, and Al-Kawar, which means the faint one. That second Arabic name is most likely the origin of the modern name Alcor. As amateur astronomy objects, Mizar and Alcor are an interesting double star that can actually be seen with the naked eye. The two stars are separated on the sky by an angular distance of slightly under 12 arc minutes, which is equivalent to slightly more than one-third the angular diameter of the Moon. Also, it's worth noting that these two stars were used at least in medieval Arabic civilizations as a type of eye test. If people could see both stars, they were considered to have good eyesight. It's possible that other civilizations also used the stars as a form of an eye test, although I had difficulty finding reliable references for this, so I can't really comment further on it. Scientifically, Mizar and Alcor are actually fairly complicated. They aren't just a single pair of stars. Mizar itself, not Mizar and Alcor together, but Mizar by itself, was identified as two separate stars by Giovanni Battista Riccioli in early telescope observations around 1650, and this is cited as the first time that a telescope was used to identify that a star was actually two separate star systems. In 1857, Mizar was also the first pair of stars to be photographed. The two star systems have been given the designations Mizar A and Mizar B, or Zeta Ursa Majoris A and Zeta Ursa Majoris B, or sometimes Zeta Ursa Majoris 1 and 2. They are separated by an angular distance of about 14 arcseconds, or about 1/130th the diameter of the Moon. If you want to take a look yourself, they should be visible as two separate objects in a halfway decent amateur telescope. In some early spectroscopic observations of Mizar A around 1890, periodic variations in the redshifting and blue shifting of the light from the star indicated that it was actually two stars that are orbiting each other. This was the first time that spectroscopy had been used to identify that any star was actually a binary star system. The two stars have masses of about 2.5 times the mass of the Sun each, and they are also a little hotter and a little more whitish in color. They orbit each other about once every 20.5 days. While Mizar A hasn't attracted a lot of attention from professional astronomers recently, it was featured in a science paper in 2012 that used it to test the application of new mathematical techniques for identifying and characterizing other binary star systems, as well as stars with exoplanets. Mizar B was also found to be a binary star system through observations of its spectra in the early 20th century. Its stars have masses of 1.85 and 0.25 times the mass of the Sun, which means that one of them is a larger, more whitish version of the Sun, while the other is probably a red dwarf. They orbit each other about once every 176 days. This system has attracted the attention of astronomers recently, in part because one of the stars in the system, which I assume to be the brighter one, is chemically peculiar. In general, spectra of stars show the presence of very small amounts of various elements in their atmospheres, and chemically peculiar stars have unusual combinations of these elements. In Mizar B's case, its atmosphere has relatively little calcium, although it does have more iron and nickel than usual. These chemically peculiar stars have a tendency to be stars with masses with a certain mass range that includes the larger star in Mizar B, and they typically appear in binary star systems like Mizar B. While I didn't find an explanation for what causes these stars to appear to be chemically peculiar, it seems like Mizar B will be very useful for understanding exactly what's going on. Alcor is also a binary star system, but it wasn't discovered to be a binary star system until 2007. The discovery was made using images from the MMT telescope made using an adaptive optics system that moves the secondary mirror in the telescope to correct for how light is distorted by the Earth's atmosphere. The brighter star in Alcor, which is also the dominant light source, is again a star that is hotter and more whitish than the Sun, with a mass 1.85 times that of the Sun's. The fainter star is a red dwarf, with a mass of around 0.3 times the mass of the Sun. Interestingly, Alcor produces a small amount of X-ray emission which seems to originate from the corona of the dwarf star. So, to recap all of the different pairings, because at this point everything's probably become a little confusing, Mizar and Alcor are a pair of objects that can be seen without a telescope if you have good eyesight. Mizar is a pair of star systems called Mizar A and Mizar B, and Mizar A, Mizar B, and Alcor are all binary star systems. That's 6 systems in 5 different pairings. Apparently, if you have good eyesight, or if you're using a good telescope when looking at anything involving Mizar or Alcor, you're supposed to have double vision. One of the interesting questions is whether Mizar A, Mizar B, and Alcor are all located physically close to each other, or whether they just happen to all appear close to each other in the sky but are actually at very different distances. The geometrical technique called parallax, where the positions of nearby stars in the sky appear to shift relative to background stars as the Earth orbits the Sun, has been used by the Gaia spacecraft to measure very accurate distances to Mizar B and Alcor. The last distance measurements from the spacecraft were published just a couple of years ago, so they're fairly new. The distance from Earth to Mizar B is 80.52 light-years, and the distance from Earth to Alcor is almost the same at 80.60 light-years. When the separation of the sky between the two stars is taken into account, they appear to be 0.29 light-years apart. This actually seems close enough that Mizar B and Alcor could be at least gravitationally interacting with each other, if not weakly gravitationally bound. For some reason, the Gaia spacecraft didn't measure the distance to Mizar A, but I did find a measurement from 1998 of 82.78 light-years. If this older measurement from Mizar A is trustworthy, this would imply that Mizar A and Mizar B are separated by about 2.26 light-years. Although Mizar A is definitely considered to be, in astronomical terms, physically close to Mizar B and Alcor, it seems a little too far from the other stars to be in a gravitationally bound system. Having said that, I would feel much more comfortable reaching this conclusion if Mizar A's distance measurement was more up to date, or if I had distance measurements to all three of the star systems from the same instrument. Finally, it's worth mentioning that Mizar A, Mizar B, and Alcor all appear to be members of an object called the Ursa Major Moving Group. While this actually sounds like a good name for a company that will help you move your furniture to a new home, this is actually a group of stars that includes most of the other stars in the Big Dipper, or the Plow, or whatever you want to call it. They all appear to have similar ages of around 400 million years, and they all appear to be moving in the same direction, which indicates that the stars are all physically associated with each other. If this group of stars was located further away, we would probably call it an open cluster. Most constellations and other collections of stars in the sky, formerly called asterisms, usually are not stars that are physically associated with each other, so it's very interesting that most of the stars in the Big Dipper, or the Plow, or whatever you want to call it, are actually part of a much larger object. So that's my review of Mizar and Alcor, and the location on the Earth's surface that corresponds to the position of Mizar and Alcor in the sky is east of Seamanoff Island in Alaska. What's cool about this is that the Alaska state flag actually has a picture of the Big Dipper on it, including Mizar. However, the state flag leaves out Alcor. Whoever designed the flag may have had bad eyesight, may not have seen Alcor. Maybe somebody can petition the Alaska state government to get Alcor added to the flag. If you enjoyed this podcast and would like to find out more, you can visit the website for this podcast at www.randomastronomicalobject.com. You can go to the website to download episodes of the show, read information about the astronomical objects, view images of those astronomical objects, and send me random feedback. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Endy at www.sasha-endy.de, which is distributed by filmmusic.io under a CC 4.0 attribution license. The sound effects are from the Free Sounds Project at www.freesound.org. Thanks for listening.